Hi everyone, this is Jesse Wilcox. Jared Cruz, Ben Herman, and I wrote a second article in this month's Science Teacher. It's a follow-up to the Sinking In article, where we were talking about mass and volume. We have students plot the density of water, and they end up getting a line right here. We have them do different masses and volumes of water, and they see that no matter what they do, the density of water is always 1. So they start to see that's the case, but then we bring in an interesting question for them. What happens if we have a piece of styrofoam and we break a piece off like this? How does this piece, the density of this piece, relate to the density of this piece? Students often don't know. They say that this one could be less dense, more dense, or the same. We get different students that say different things. So we have them do an investigation with that. These float. We also have them do an investigation with marbles that sink. And they try and figure out what would the density be like if they had multiple marbles versus one marble. After they've done their investigations and we ask them a lot of questions, they come to the consensus that no matter how much of the material we have, we get the same density. And that's where we want them to be for a moment. We push their thinking on that a little bit by showing them hot water and cold water in a density box. We pull open the divider, and what they see is that the hot water's on top and the cold water's on the bottom. And that confuses them a little bit because we just talked about that if you have the same amount of material, the density should be the same. We continue with modeling through questioning and other investigations to have them see what happens to the particles that makes a density change in this. That applies to a number of different areas that we discuss in the article.